we're now going to look at example number 7. The question asks us to find the area bounded by y equals square root minus x plus 2, the y-axis, the lines y equals 0, and y equals 2. So, first of all, to get a better view of the question, it is best for us to sketch the graph. So remember how to sketch your third graph. So, minus x plus 2 must be greater than or equals to 0, because it has to be positive. So minus x is greater than negative 2, so x is lesser than or equals to 2, so this will be 2. Okay. So this will be your square root minus x plus 2 graph, and then you have y-intercept here. So you have a y-intercept here, so your y-intercept is when your x is equals to 0. So to find the y-intercept, you would need to substitute x equals to 0 in your function. So when you substitute x equals to 0, you'll get y equals set 2. So this will be your set 2 will be your y-intercept. Okay, so now the question tells us that the boundaries will be the y-axis and the lines y equals 0. So this will be the line y equals to 0, so the x-axis, and y equals to 2. So y equals to 2 will be somewhere here. Okay. So now the question asks us to find the area bounded by the curve, the y-axis, and the lines y equals 0 and y equals 2. So what I'm going to do now is I'm going to highlight the boundaries so we can identify easily the area bounded by the curve and also the other boundaries. So this is y equals to 0. So this is equals to y equals square root minus x plus 2. So I'm going to label it y equals square root minus x plus 2. So this is your y-axis. So this whole thing is the y-axis. So this will be your y equals 0. And this will be your y equals 2. Y equals 2. So look at your graph carefully. You can easily identify these two areas as the area bounded by the curve and also the other boundaries, because these two areas are the areas with its borders highlighted. So that's how we know that this is the area that we want to find. Okay, so now we have two highlighted areas, so we can label it area 1 and also area 2. So we'll find area 1 and then we'll add area 1 with area 2 to get the total area bounded by the curve and also the other boundaries. So right now, if you notice, your function is in the terms of x. So when you want to find the area of the region bounded by the curve and the y-axis, your function has to be in terms of y, because you'll be integrating it with respect to y. So you must transform or you must change this function into terms of y. So y equals square root minus x plus 2. So y squared is equals to minus x plus 2. Y squared minus 2 is equals to minus x. Minus x is equals to y squared minus 2. X is equals to y squared minus y squared plus 2. So this will be your function in terms of y. So now, how do we go about finding the two areas? So for area 1, we can take the integral from 0 up to set 2. So 0 to set 2. And then we'll take the right function. So your right function is x equals minus y squared plus 2. So this was the original function. Then we have changed it and make it in terms of y. So we'll use the one which we have changed in terms of y. So minus y squared plus 2. And then your left function will be this function. So left function will be x equals 0. So you'll minus 0. And the whole thing, you'll integrate it with y. So you put dy. So now, you can simplify further, and you'll get minus y squared plus 2 dy. Okay, so now you integrate them with respect to y, you'll get minus y cubed over 3 plus 2y set to 0. So you'll get 4 set to over 3, and this is also equals to 1.886 units squared. So we have already obtained E1. So now we are going to find E2. So for E2, we are going to integrate from set 2 up till 2. So from set 2, our integral will be from set 2 up till 2. And so our right function will be x equals to 0. So this will be 0 minus our left function. Our left function, this is our right function, and this is our left function. Left function will be minus y squared plus 2. And the whole thing will integrate with respect to y. So we put dy. So simplify further, we'll get y squared minus 2 dy. Then integrate with respect to y, we get y to the power 3 over 3 minus 2y 2 set 2. First bracket gives you negative 4 over 3. Second bracket will give you another minus 4 set 2 over 3. So you add them up and you get 0.5523 unit squared. Okay, so this is for your E2. So now our total area, so our area is equals to E1 plus E2. So our area will be 1.886 unit squared plus 0.5523 unit squared. So you add them up and you'll get 2.4383 unit squared. So this will be our total area bounded by the curve, the y-axis, the lines y equals to 2, and also y equals to 4. Okay, so now we are going to look into example number 8. The question asks us to find the area bounded by a curve x equals y squared and the line x equals 4. So as you can see, I've already sketched the graph. So this is the curve x equals y squared. So I'm going to label it x equals y squared, and this is our line x equals 4. So this is line x equals 4. So the question asks us to find the area bounded by the curve and also the line. So I'm going to highlight the curve and also highlight the line. So this is our curve, and I'm going to highlight in red our line x equals 4. So now you can clearly see the area which is bounded by these two boundaries. So this area right here, the one that I'm shading, is the area bounded by the curve and also the line x equals 4. So this is actually the area which we want to find. So how do we go about finding it? So first of all, to find the area of the region bounded by the curve and the y-axis, we take the interval EB and we take the right function minus the left function, and we integrate the whole thing with respect to y. So we put dy. So in our case here, our right function is x equals to 4, and our left function is x equals to y squared. So this is obviously on the left hand side of this line. So this is the right function, and this is our left function. So remember, when we want to find the area of a region bounded by the curve and the y-axis, our function has to be in terms of y. So our function is really in terms of y. We need to know the interval in which we will be integrating. So this is what we don't know now. But as you can see, the interval, or the a and b, is actually the intersection between the curve x equals y squared and also the line x equals 4. Therefore, we need to find the points of intersection first. So the points of intersection of first the curve x equals y squared and the second function x equals 4. So how do we find the points of intersection? To find the point of intersection, we equate 1 with 2. We equate the first equation with the second equation. So when we equate them, you will get 4 equals to y squared. So y squared is equals to 4 and y is equals to plus minus 2. This is obviously, this is positive 2 and this is negative 2. So this is the interval which we need when we integrate. So now we already knew our right function and also our left function, and we knew already our a and also b. Our a is equals to negative 2 and our b is equals to 2. So now we could simply integrate them with respect to y. So our a will be negative 2, our b will be 2. Our right function is 4 and our left function is y squared. So the whole thing will integrate with respect to y. And so integrating it, we'll get 4y minus y cubed over 3. Substitute 2 minus substitute negative 2. So in the first bracket, you'll be getting 16 over 3. And in the second bracket, you'll be getting minus 16 over 3. So when minus meets minus, you get 32 over 3 unit squared. Remember to write the unit. So that is how you solve questions like this.